Wow, that looks so beautiful from up here. Stop looking at our plane and start flying. We're flying behind our attack. Look out for that meteorite!
Baby, you're a firework.
Whoa! Whoa!
Are you okay?
Yeah, I'm fine. But where'd our squadron go?
Oh my god. I think we're lost. The radio stopped. We've been driving around for more than a day. I think we're lost. We're almost out of fuel.
Hold on. What's that speck in the distance over there?
I think it's a planet.
Okay, good. Let's get into range.
Yeah. Okay, let me get NASA on the line.
Hello? Houston, we have a problem.
What is your ship number?
We are ship number 2369MZ.
Roger that, 2369MZ. We have just located your exact position. We will send out a rescue team as soon as possible.
Roger that.
The rescue team will arrive in T-minus 48 hours.
We need to conserve our gas for 48 hours until the rescue team arrives.
I have an idea. Why don't we orbit this planet to help them?
Good idea, Zane. But we need to find the velocity to get into orbit.
Okay, assuming our current motion, I've calculated that we will be exactly 7,000 kilometers away from the center of the planet in 20 minutes.
Alright, let's do the math. So what we're looking at is, this is the planet right here. It's center right here. And we're coming in on this path. Right when we're here in 20 minutes, we will be 7,000 kilometers, which is the radius from the center, and that's the radius of our orbit. At this point, if we reach the correct velocity of orbit, our velocity will be straightforward. However, the acceleration will be inward. And due to this, our path will be curved. And this will keep on taking place where velocity is constant and acceleration is constant, always pointing towards the middle, which is centripetal force because it's center loving. And our spaceship itself will want to eventually hit the planet. However, the planet will keep on curving under us, so as we keep going, we will only be orbiting, but we'll never hit the planet. And that's why this velocity is so important, and which is why we need to find it in order to conserve gas. In order to find the velocity needed to get into the orbit of this planet, we must go over the fact that centripetal force is equal to the gravitational force. And centripetal force is...
Centripetal force is a force that acts on a body moving in a circular path and is directed toward the center around which the body is moving.
So we know that centripetal force is equal to m1 times velocity squared over r. And that it's equal to the gravitational force, which is the gravitational constant times m1 times m2 over r squared. The m1's cancel out, so you're left behind with v squared over r equals the gravitational constant times m2 over r squared. Now what these letters mean is the velocity, which is what we're trying to find, velocity squared. R represents the radius of the orbit, so how far away you are from the center of the planet. And g is the gravitational constant, which is 6.67 times 10 to the negative 11th. And m is the mass of the body that we're orbiting. So to even simplify it more, we get v squared equals gravitational constant times the mass of the body over radius. One more step equals v equals square root of gravitational constant times the mass of the body over the radius. Now if we plug in the numbers that we have known, v equals the square root of 6.67 times 10 to the negative 11th times our calculations in our spaceship tell us that the mass of the planet is 6 times 10 to the 24th kilograms. And like we mentioned before, the radius of our orbit in 20 minutes will be 7,000 kilometers, which is actually 7 million meters. So when you do the math, you get the velocity equals 7,561.18 meters per second. And this gives us the solution to the problem of the velocity needed to get into the orbit of this planet at 7,000 kilometers above its center.
10 seconds away from the point of orbit.
According to our calculations, we need to be at a velocity of
7,561.18 meters per second.
Be careful, boys. It's dangerous trying to catch orbits.
3, 2, 1, do it! Alright, we are traveling exactly
7,561.18 meters per second.
We're successfully in orbit.
This is Houston.
Roger that. This is 2369 MZ.
We're sorry to inform you, a NASA rescue team will not be able to reach you, as you are out of our reach. Contrary to what the last operator said, which got him fired. You are currently traveling in dead space. We will shortly lose contact with you permanently. Good luck to you. May God be on your side.